Hi guys, when we talk about functions, one of the most important parts is domain and range that some people tend to struggle with. Today, I'm going to be explaining domain and range and teaching extremely easy methods so that you can ace it. My name is Angad and you're watching Learn with Angad. So let's get into it. So before we get into domain and range, let's understand what a function is. Supposing if you have f of x is equal to x plus 4, find f of 4. All you have to do is substitute a value 4 instead of x in the equation. So you get f of 4 is 4 plus 4, which is 8. Now let's try a similar example. Suppose if you have g of x is equal to x square plus 4x plus 5. Find f of minus 1, g of minus 1. So now all you have to do again is replace the value of minus 1 and replace it with, instead of x, you write it there. So you write minus 1 square plus 4 brackets minus 1 plus 5. This is 1 minus 4 plus 5, that is 2. So g of minus 1 is 2. So this is the basics of function. Now that you've understood it, let's move on to domain and range. So the definition of domain is the values of x can take so that the function is defined. Now what that means graphically is that domain is defined on the x-axis from left to right. Okay, so we can check where the curve starts on the LHS and ends on the RHS. So let's just do some examples to get through with this concept. Supposing you have a graph on the axis and it goes from here to here. These arrow means that it extends to infinity. So now this will go from negative infinity to positive infinity. That means x can take any real number value and the graph will exist. So the domain of this function will be x is a subset of any real number. Okay, now let's move on to another question. Let's move on to, so what, supposing you get a function like this and over here a closed circle and an open circle, minus 4 and 5. Okay, so a closed circle, like when it's colored inside, means that that value is also taken into consideration, whereas an open circle where there is a gap inside means that value is not taken into consideration. So the domain in this case from the left hand side to the right hand side will be minus 4. So x is greater than minus 4, which is less than equal to 5. Now why is that greater than and less than equal to? Less than equal to is because of the closed circle, the value is taken into consideration, whereas there's no equal to on the first side because it's an open circle, the value isn't taken into consideration. Now that we know how to find the domain graphically, let's do it algebraically. So a golden rule to remember is that a function is not defined if the denominator is 0. So to find the domain, we can simply equate the denominator of the equation to 0 and we will get the value, and the value we get will not be included in the domain. For example, if you have f of x is equal to 4x minus 4. What we'll do is, to find the domain, simply equate x minus 4 to 0. We get x is equal to 4. So our domain will be x is a subset of all real numbers and x is not equal to 4, because at when the point is 4, the graph doesn't exist. Let's do another example. So supposing if you get 3 by x square minus 9. Again, we simply equate this x square minus 9 to 0. We'll get x square is equal to 9. X is equal to plus minus 3. Okay, so now the domain for this function will be x is a subset of all real numbers, but x is not equal to plus minus 3. As at when the point is plus and minus 3, the graph doesn't exist. Let's do a final example to be thorough with this concept. Supposing you get g of x is equal to 5 1 plus x square. Simply equate 1 plus x square to 0. You get x square is equal to minus 1. Now note, so then x is equal to root of minus 1. Now we know that root of minus 1 is not a real number, it is undefined. So the domain for this function will be x is a subset of all real numbers. That's the domain, since root of minus 1 does not exist. Now let's move on to range. Range is graphically, so range is values y can take so that the function is defined. Graphically, range is calculated on y-axis from bottom to top. Algebraically, it's a bit more complicated, so I'll be talking about it in detail in another video, but for now I'll just give a basic definition. So first we find the inverse of the function, and then we find the domain of the inverse. The domain of the inverse will be the range of the main function, so that's how we find the range. It's a bit more complicated, there's more things to talk about, so I'll covering it separately in another video. So now let's just focus on graphically. So suppose you have a graph from here to here. This is minus 3, negative 3 extends. So we need to find the range. The range will extend from this point to, and it will keep going upwards from bottom to top. So the range will be y is greater than equal to minus 3. Since at the point minus 3 the graph still exists. So that's our range. Let's try another bit more complicated example this time. So let's find the range in this example. Now we need to find from bottom to top. So we'll take the bottommost point, which is minus 8, and the topmost point, which is positive 5. Okay, sorry, my diagram is not to scale, so please don't take it too literally, just focus on the points. So the range will be y is greater than equal to minus 8, since it's a closed point, that point the value is included, and y is less than equal to 5. This will be our range. Okay, now that we are clear with range, now let's try some sums where you're going to find the domain and the range. Now we need to find the domain and range of this graph. So let's start with the domain. Domain always starts from the left to the right. Now you can see some dotted lines over here. These dotted lines mean that the function is not touching that point at all. This is called an asymptote. I'll be covering this again in more detail in a future video. So this is just called an asymptote. It basically means at that particular point the function is not touching. Okay, so if we need to find the domain, we will. So the domain will be x is all real numbers, but x is not equal to minus 2, x is not equal to 3. Because we can clearly see with the help of the asymptote lines that the graph is not touching at minus 2 and 3 respectively. So that's our domain. Now to find the range. So the range is y is all real numbers. First let's get that. Now we can see that the range is from this point minus 1, and it keeps going to infinity, and it starts from here and it starts from 0 to infinity. It doesn't start from 0, it doesn't include the point 0, but so it's like a open circle over there. So how will we write this as? We will write the range as y is all real numbers, y is less than equal to minus 1, and y is greater than 0, because the point 0 is not included in the range. So that's our graph. So that's if you get a graph to find domain and range. Now let's do some algebraic sums. So y is equal to root of x minus 4. This is a different type of sum. Okay, so now if you have the sum, whenever you have a square root symbol, range will always be y is greater than equal to 0 whenever you have a square root symbol, because whenever you have a square root symbol the graph will always be positive. Since a negative number under the square root sign is undefined, it does not exist, so the graph will always be positive. Now we know that, and if we sketch this particular graph, over here. We can sketch it on a GDC if you want. So the graph will look something like this. Okay, it keeps extend, so the range, it starts from 0 and keeps going on till infinity, and the domain, it starts from 4 and keeps going on till infinity. So the range is y is greater than equal to 0 and the domain is x is greater than equal to 4. So that's all. Now you're a master at domain and range. Thank you for watching this video. Make sure to subscribe and hit the bell icon for future videos. If you have any doubts, do let me know in the comments below. But for now, peace. Before I end, a quick shout out to my really good friend Ranbir Tharani for supporting my videos. Thank you so much, bro. It really means a lot to me. Okay, bye.